Okay, so the next thing in our notes are looking at expansions of binomials, which binomial just means two terms. So we've got one term here and another one. And we're raising this expression here to some power n. And we expand these using what's called the binomial theorem. You've already expanded some things like perfect squares. So say a plus b squared, for example, you'd be able to expand. We're looking at a binomial theorem here, which just allows us to expand bigger powers. Okay, so if we have a look at these expansions, a perfect square results in this expansion. So we know a plus b squared would give us first term squared. The second term squared over here, and in the middle is twice the product of a and b, so 2ab. If our power of 3 is 3 instead of 2, then we get a cubed plus 3a squared b plus 3ab squared plus b cubed. We haven't looked at perfect cubes yet, but we will. And if our power is 4 is this. Now what we want to look at is a way of expanding these without having to write, in this case here, a plus b times a plus b times a plus b times a plus b. So what we can use is something called Pascal's triangle. Okay, by looking closely at what we've got here, we can see that there's a pattern in the powers of a and b. The first term in the brackets after expanding begins with having a power of the value n, and its power successively decreases by 1. So let's have a look at this one here, which is easy to see. So we've got our first term here to the power of n. Our n power is 4. Okay, so we've got a to the power of 4. Then our power of a becomes 3, so that's 1 less, then becomes 2, then becomes 1, and then becomes 0. The second term in the brackets, okay, so our b, okay, once we expand, begins with a power of 0, then it successively increases by 1. So then it becomes b to the power of 1, then b to the power of 2, b to the power of 3, and b to the power of 4. The coefficients of each term in the expansion can be found using Pascal's triangle. Okay, so what we've got here, this is Pascal's triangle. If you're not familiar with that, the pattern that we can see here, we go down here in the triangles, they're all 1s. And then the next diagonal here goes 1, 2, 3, 4, 5. And it goes this way here as well, 1, 2, 3, 4, 5, and so on. If we look at it vertically, we can see that here each number down is found by adding together the 2 above it. So this 2 here is found by going 1 plus 1 to give 2. This number here is 1 plus 2 to give 3, 2 plus 1 to give 3. And then this row here we've got 1 plus 3 to give 4, 3 plus 3 to give 6, 3 plus 1 to give 4. Okay, and so then we can get the next row as well, which is 1, 5, 10, 10, 5, 1. They're found by doing the same thing. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5. We could get the next row as well. Okay. So these numbers here correspond to the coefficients. So if we have a look at this expansion here, a plus b to the power of 4, the coefficients are 1, 4, 6, 4, 1. So this is our n value of 4, and here's our coefficients 1, 4, 6, 4, 1. So if we had another one, a plus b to the power of 5, the coefficients would be 1, 5, 10, 10, 5, 1. Okay, so study the pattern and make sure you understand how we get it. The other thing too is the values of the coefficients listed may also be found using the NCR button on your calculator. It's also written as N over R here in these larger brackets. There's a formula which we'll see in the probability section. It's also in your information sheet. So see how they work by considering the bottom here. So this row here which corresponds to a power of 5. That's our n value. So the NCR, our n is 5. The R value, that's the position. Now the first position here is the 0 position. So it goes 0, so 5C1, or sometimes referred to as choose, 5 choose, 0, sorry, not 1. So 5C0, 5C1, 5C2, 5C3, 5C4, and then 5C5. And that's the last one. There is no other one after or before it. If we had the next row, it'd be 6C0 going all the way to 6C6. Okay. This row here would be 2C0, 2C1, and then 2C2, and that's all. Okay, so that's how that works, and that's the notation for it. Okay, so what we need to look at is this is our A term and this is our B term. Okay, so if we think of it as A plus B to the power of 3, 2x is our A and 3 is our B. Okay, so I'm just going to put over here the Pascal's triangle. We've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and because this one here's a power of 4, we need to go here, which would be 1, 4, 6, 4, 1. Okay, that's just to help us with our coefficients. Okay, so for this one here, these are our coefficients, and we start with a 1. So I'm just going to put equals. First coefficient is 1, and then it's 2x to the power of 3 times 3 to the power of 0, which is 1. So we'll just leave that out. That's the first term when we expand. Plus, the next term we get when we expand, we'll have, this is our coefficient, 3, times 2x to the power of, now it's 1 less, so that's the power of 2, and then it's times 3 to the power of 1, plus 3 is our next coefficient, times 2x to the power of 1, because it's 1 less than this one, times 3 power of 2, because that's 1 more than this, and that's that term. And then the last term, that's our coefficient, which is 1, times 2x to the power of 0, which is 1, so we can leave that out, times 3 to the power of 3, and that's the last one. So with the power of 3, there are 4 terms, okay, because that corresponds to here. So we've got 4 coefficients, so it's 4 terms. And now we can expand it and simplify it. So 2x is, all of this is raised to the power of 3, so that becomes 2 to the power of 3 times x to the power of 3. So that, and then times 1. So that's 2 to the power of 3 is 8 x to the power of 3. And if we look at these, so we can expand these here. This will be 2 to the power of 2, which is 4 x squared. Now the 4 will be multiplied by that 3 and by that 3 as well. So 2 squared is 4 times 3 is 12. 12 times 3 will be 36. So that's 36 x squared, because the x is squared as well. And then here 2, that's all the power of 1, so that's 2 times 3 is 6 times 3 squared, so that's 9. Okay, so 2 3s is 6, 6 9s are 54. So that's plus 54 x. And then the last one here, 3 to the power of 3 is 27. And that's our expansion. If we have a look at this one here, I'm just going to put a little line down here just to divide these two questions. Same thing now. Our power here is 4, so this is what we've got here, and we're going to have 5 terms. So the first coefficient is 1, and it's 1 times 3m to the power of 4 times this term here, the power of 0, but we can leave that off. That's m there. All right, so I'm just going to put a plus in between, because this negative, you'll see what happens. Next coefficient is 4 times 3m to the power of 3 times, now we're going to consider this as 3m plus negative 2n power of 4. So this here, our next term, our b term if you like, is negative 2n. So that's how we deal with the negative. So that's negative 2n to the power of 1 plus, whoops, 6 is our coefficient, times 3m power of 2 times negative 2n, that's now to the power of 2. So you'll see here the 3m's are going down by 1 each, so power of 4, power of 3, power of 2. The negative 2n's are going up by 1 each time, so it's negative 2n to the power of 1, that's the power of 2. And the next one here, 4 is our next coefficient, times 3m to the power of 1 times negative 2n to the power of 3 now. And then the last one is plus 1 times negative 2n to the power of 4. And we're going to expand these here. So 3 to the power of 4 is 81 m to the power of 4. Well, before I go, that's not actually going to be plus, because if we have a look here, we've got positive 4 times, now this will be 3 cubed is 27, and that's positive as well, but this is negative times negative 2, so we've got positive times negative, so it's going to become minus 4 times 27, so we've got 4 times 3 cubed, so that's 4 times 27 times negative 2, we're going to have minus 216 m cubed n. This one here, we've got positive times, this will be positive as well, and this will be positive because it's negative raised to an even power. So it's positive times positive times positive, so that's plus. 6 times 3 squared is 9, so 6 nines are 54 times 4. 54 times 4 is 216 as well. And that's m squared n squared. And then this one here is going to be minus because we've got positive times this will be negative when we expand that. So that's minus 4 threes are 12, 12 times 8, this becomes, so that's 96 m n cubed, and then this will become positive, so that's plus 16 n to the power of 4. And that's that expanded. Okay, so that's how the binomial theorem works. So study that again, watch it again if you need to. Ask me any questions, I can clarify that.